Hey everybody, how's it going? I haven't done one of these for a while. I thought I'd do a quick test. Get this, there we go. Should be working now. Checking the video setup here. Funny how I don't hear it on here yet. Very strange. Oh, there we go. It's just low on here. Okay, I can kill that. I got my framing right here. Just about. Make this window a bit bigger so I can see what I'm doing. So first thing I was going to do, I was going to talk about some upcoming events, comets, asteroids, some other general observation stuff, a couple of websites, things like that. And thanks to everyone who joined recently, got me up to the count so I could do some live streams on mobile. I thought I would just take advantage of that and do a quick thing. Instead of setting up OBS, just use my iPhone. And instead of using a webcam, I'll just use the iPhone as a webcam. And I can zoom in on the screen later. It works out pretty well on the laptop if I do it that way. So, if you're wondering what this tape is, I had to tape an extra fan to the bottom of the laptop because it was running extra hot today. Just very warm in here. I ran some AC, but I was trying to not get it too cold in here. But it's running a little hot. You can feel this upper area is getting quite warm, so in order to pick up the laptop easily and not lose the fan position, I just basically taped it to the bottom of it. It looks real ghetto, but it's okay. So first and foremost, I'm going to a couple pieces of gear, depending which kind of scope you have. You may or may not come across this stuff, but it's just some things to think about if you do end up getting a better scope or start getting into buying stuff, some of the accessories you'll need. If you choose to get a go-to scope, you'll get a little computer like this. This is from my Mead astrograph, the one I do the live streams on. And obviously it's not plugged in now, so there's no light up here, but it ties into the console of the scope, also ties into the both motors and right ascension and declination. In case you don't know, declination is celestial latitude, and right ascension is celestial longitude. So just different words for the same stuff. It's just the coordinates on Earth projected into the sky and given different names. So right ascension is in hours, minutes, and seconds, and declination is degrees, minutes, and seconds. But anyway, so this has an object database. It's several thousand. I think it's like 20,000 objects, maybe more. Everything from, obviously all your solar system objects, your some asteroids. It's not updated to have comets in it. You could probably do that at some point, but this one has not been updated from what I've seen. I've never hooked it up to anything to update it, but there are ways to update it, I think. But all the deep sky stuff, galaxies, nebulae, various other things, even quasars, double stars, everything you'd want to look at pretty much can be in here. Now I might be pushing the limits of the scope because they'll tell you the magnitude. And just to give a quick rundown for those who are new to this stuff or fairly new to it, magnitude is a measurement of brightness of an object. and it's essentially like a logarithmic scale, and it actually, the lower the number, the brighter it is. It's kind of a weird thing, but without getting too technical, the sun is like -29 magnitude on a very good day without clouds and all that kind of stuff. And Jupiter can often be around -2 magnitude, -3, something like that. The limiting magnitude of your naked eye in good conditions with no light pollution, dark skies, eyes adjusted to the dark, your pupils have opened up. It's about 7, magnitude 7, maybe a little more if you're extra lucky. So all the fainter stuff, like, often Pluto, for example, is around somewhere between 11th and 12th magnitude, sometimes a little fainter than that. So even if your eyes could see it, it's very, very small. So it's a combination of how big the object is, how bright it is, various other aspects of that. So even though you have a large object, it could be fairly faint. There's a huge globular cluster in the southern hemisphere called Omega Centauri. It's beautiful. It's almost the size of the moon from our point of view, and its brightness is not. It's very kind of washed out, very faint. You can see it naked eye if you're well adjusted and you get the right seeing conditions. Even from here, even though it's a southern object, you can see it from here, like in the spring, with a really good horizon to the south. And I've seen it once or twice. It was pretty cool just because it was so big, but it wasn't anything to write home about. Now, once you get it in a scope, it looks pretty good, but it's very diffuse. So magnitude is it's not just how bright it is, it's also how big the object is, how good the seeing conditions are, with the stability of the sky, local clouds, moisture in the air, all kinds of other stuff. So when they say seen, it usually refers to the atmospheric conditions. But magnitude plays a big part in all that. So anyway, so it'll tell you all that kind of stuff in here. And there's some controls to zip around the motors like a video game. And you can punch in stuff directly with this, and it's very clever. And you can even hook, there's an extra port on the bottom to plug it through an adapter to the computer. And so you've seen on some of my streams where I've had Stellarium running, and when everything was set up correctly, I had time to adjust everything. Stellarium was actually the object on screen with a crosshair on it was the object in my scope. And when I slewed the scope, left, right, up, down, you see the sky updates on the computer because it's tied to the computer on the telescope. So in an ideal situation, it's really cool actually, because it's fun for visuals, so you can kind of see what I'm doing. It also helps me occasionally not have to look at the scope, but I can see where I am to remind myself where I need to go to next, things like that. So it's an educational tool as well as a useful tool for just jumping around. And in special setups, you can actually have your smartphone hooked up the same way, and the software will have the app moving around, objects moving around the screen in sync with the telescope. So very, very cool. So you can actually just pick an object on here or on the computer and say go to it. It goes shh, and you hear the telescope moving, and it goes there. So it's much easier than using the control box. But this is good to know. This is old school to a certain extent. I've used even more old school than this at observatories with just a RA deck control box. It's just like 4 buttons hooked to motor drives and using star charts to find my way around with setting circles. So that was kind of the dark ages, the old days. Some people still do that, but it was a useful thing to learn. So there's if you get a fancier scope called a go-to scope, they have some kind of computer with Meade, Celestron, various other companies have those kind of things. And then when you get into looking around on your scope, this is a compound thing I put together, but normally you have your little finder scope. It's like a mini telescope here. I lost the cap, so I put a little saran wrap on there, but this is your mini telescope to add on with, they often have little crosshairs in them, but not always. And this is your, once this is put on the scope body and everything is lined up right and you've calibrated it, so it's, when this object is in here, it will be in the eyepiece on a low power at least. Unless you really zeroed it in, and it'll be like, even on a higher power, you'll pretty much be close to the center. So this is quick and dirty finding stuff if you're not using the computer. It's kind of cool. Another cool thing to add, I had this bracket put together because normally I was using just this. In the old days I would just use this. But sometimes it's at a weird angle, or you just want to, I know the sky well enough, I'm quick and dirty, I don't need to actually see the object, I just need to know the region of the sky to go to, called star hopping. So I use this little guy called Easy Finder, and there's a little switch here, and you won't be able to see in here, I don't think. Let me get, I don't think you can see the dot in there. Maybe you can. It's not that bright in this room. Anyway, it projects a red dot on the scene, superimposed over your viewpoint, and it's a adaptation of an old Army tank technology called the Telrad, where you would have an optical finder with a red beam projected on the real world right in front of you. So instead of using a scope where you're narrowing your field of vision and cutting your light level down and being more precise, this is a general rangefinder to put your object, basically paint it with a laser, essentially, even though the laser doesn't go out, but it's still an LED in here. You're basically painting a target inside in your eye, and find it. There it is. Go look at the scope. Hey, look at that. There it is. So it's a quick and dirty way to find things if you know the sky well enough, versus having to actually look through here. Oh, there's the object, and then go check your scope for fine settings. So I put them both together in a single bracket, just so in case I ever want to use them both, I can, but I mostly just use this guy. That's my favorite. So there's that part of it. And in order to set up a scope, if you have a mirror-based scope, like a Newtonian or a Schmidt-Cassegrain, you have to do this thing with the optics called collimation. So let me scroll down so I can see the chat, in case there is any chat. Hey Neil, what's up? This is all old hat to you, so you're going to get bored by some of the gear stuff here, but I'm just presenting some gear to people who don't know some of this stuff. So, and because my iPhone is facing the other way, I have to use the computer camera to see what I'm doing. So, the computer view. But so when you want to collimate your optics, you have a primary mirror. So in the case of a Newtonian, the big mirror at the bottom is your primary mirror. It's the light bucket at the top gathers all the light, shoots it down the primary mirror. It focuses the light up to a secondary mirror up near the eyepiece, and at some point it hits the secondary mirror, and then it shoots over to the side where the eyepiece is, and then you focus your eyepiece from there. Well, shifting the telescope around, temperature differences, all kinds of, driving the telescope to the site shakes it a little bit, it gets out of alignment. So you have to use this thing called collimation, this process. And so again, there's another type of little kind of a laser thing here, this collimator, which actually shoots a laser, little red laser, down into the primary mirror from the eyepiece. So I put it in the side, it's hitting the secondary mirror, going down to the primary mirror, and then from the top I can look down the top of the tube, and I can see there's a little donut they put in the middle of the primary mirror, and you want that little dot to be right dead center on the primary mirror. But before I can even get to that point, you have to go to the back of the scope, turn a bunch of screws to move the primary mirror enough so there's this little thing right here shows me there's a light on here. So I'm looking back there, I can see that it's on, and I'm looking at the image on here, And as I'm turning the screws, you'll see this kind of rough image of the laser going back and forth. And there's a point where it gets blocked. And that is a good thing, because blocking means it's hitting the secondary mirror. So you move it to the little red dot, kind of goes behind the block here and behind the block X and Y. And I go, okay, cool. Now I can go to the front of the scope and see if I'm close to the donut. If I'm not close to the donut, I can use a small screwdriver and adjust the little screws on the secondary mirror until it hits the donut. And that's basic collimation. Really simple. You can spend a long time doing it, or you can do quick and dirty like this thing does. But very cool. These things are only like, I don't know, 25, 30 bucks in most cases. So you have your optics when you're using the scope to find objects. You have the optic aid to set up the scope, with collimation for a mirrored telescope. A large refracting telescope, which is basically a giant version of this, is fixed. It doesn't have to be collimated. It's just lenses, goes to your eye. That's all you have to do, really. You don't have to think about it. But the big light bucket scopes with the mirrors, you have to adjust them and make sure they're calibrated and collimated. And you want that to be as clean as possible, because you're looking at faint objects, sometimes very small. So you're going to be potentially zooming in with the bigger eyepieces, maybe not. And you want all the little details you can get. So if you're not collimated, you're just going to get an image that's poor quality or just kind of fuzzy. So you spend a little time doing that when you set up. It's not that bad. You get used to it. Another thing you do is you use eyepieces. So here's an example of a basic inch and a quarter. So the really cheap department store telescopes have a 0.96 inch eyepiece standard. This is inch and a quarter. And then there's a 2-inch size. So this one here is a zoom eyepiece. And it starts with a 2-inch diameter. But what's clever about it is you can actually unscrew this, and there's an inch and a quarter in case you want to use it on a smaller scope. But if you have a bigger scope, most of your fittings are going to be set for 2-inch. So you put that on and you're good to go. And then you have this zoom eyepiece to give you variable zoom. The cool thing about this is not only can you get different views of different objects without changing eyepieces, but in some cases where you have an object that is needs a little more contrast, just by boosting the magnification, you'll make the image a little bit darker, a little more contrasty. That little adjustment can help make the view better on certain objects and certain seeing conditions. So just little tricks like that you learn along the way. This is made by a company called Bader in Germany. And pretty nice. The other cool thing about the top is you take the eyepiece cup off the top, and it has these universal threads on it, which are the same as some of these spacers and ring adapters and things like that. So if you can actually put a T adapter for a camera directly on this eyepiece. And I'll get to the camera stuff in a second here, but just showing you that some of these eyepieces have other things, other tricks up their sleeves. They're not just regular eyepieces. So this one is zooming and also has threads on it for photography and filter. You can also there's a thread inside the bottom to put different kinds of filters in there too. So all in one eyepiece, you have all these little tricks. So if you do get into photography, so for example, this is a 2-inch adapter, which goes down to a 0.9, it's an inch and a quarter adapter if you want it to. Has a T adapter on it that screws into your camera. And in this case, this one also holds a center collar to put an eyepiece in it for eyepiece projection to get closer images. It's an older style way of doing things. Most people don't do eyepiece projection anymore. My early live streams, I did some eyepiece projection, and you'll see depending on the camera setup and the eyepieces you're using, stuff like that, sometimes you get a weird tunnel vision effect where it's perfectly sharp in the center and kind of this stretching of the perimeter of the image. As you go out toward the edge, it starts to get kind of stretched and maybe fuzzy. So it's not a great system unless you totally dial in every piece. But it was the old way of doing stuff when you had like old SLR cameras for film. You didn't have a lot of mounting options. You didn't have a lot of other kinds of tricks along the way. So the only way to get the image bigger on your film, which is limiting compared to the high-res digital stuff now, you would have to make the image bigger on the film with an eyepiece. And then you could also blow it up further if you needed to in the dark room and stuff like that. But so eyepiece projection is like an old-fashioned way to do that stuff. But what's cool is you notice this is the same size. And these are actually individual rings of different lengths. So you can unscrew all of these and use them as extender rings. Sometimes when you go to photography, your tube is not long enough to stick out of the thing to reach proper focus, depending on the focal length of your telescope, a bunch of other stuff. So you occasionally need these rings to extend this tube to go further out of the locking nut on the telescope itself. But again, it's this universal thread size. I think it's 43 millimeters? I think it's 43 millimeters. They call it I'm drawing a blank on the name now. There's a specific name for it. It's not an Orion adapter. It's it'll probably come to me later, but it's not that important. So that's one way of doing this. Another way is on my Nikon mirrorless camera. I have this special adapter that just goes straight to the camera body. No optics going through at all. It's just totally open. You'd really want, as much as you can do, no optics between you and the image, other than the telescope, obviously. So this is just a pass-through that has the right fitting and the right distance, so the focal range will work out properly without having to use extenders. But see, it's got the 1.25" guide. It goes in the standard eyepiece. I could easily screw into the bottom of this a 2-inch if I want to use it with a 2-inch, or get a slightly different version of this. But it's kind of a passive device that helps me do some of the live stream stuff with the camera. Also, if I want to use other types of adapters, like this is an older Nikon type T adapter, will not work on my newer Nikon camera. But if I adapt it to this coupler here, I can actually use old Nikon lenses and old Nikon adapters with my new Nikon camera. So the other adapters sometimes you have to buy along the way to make that all work. So that's all cool. What else do I have here? So covered the optics, we covered the collimation. Yeah, when you get into observations, sometimes you need to put filters on things. So this is a special filter for Jupiter to give it this, it's kind of a dark bluish tinge to give you contrast on Jupiter. Sometimes Jupiter, unlike in the photos, is kind of washed out. It's very bright, and sometimes you want to just pop out some features. So you put this little Jupiter filter on there, screws into the eyepiece at the bottom. So it's that same 1.25" size. So that's good for observational, not so much for photography. And other cool observational filters you can get. This is really only used for a handful of what they call planetary nebula, which is a star that has gone through getting near the end of its life, and it basically collapses from the gravity winds. The fusion is slowing down. A lot of things have turned from hydrogen, helium to way heavier elements. There's not enough fuel to fight gravity. The star collapses, and it's not massive enough to be a supernova. So you end up getting star shrinks, and then it shoots off a shell of gas, and you get these things called planetary nebulae. And there are only a couple of them that use this filter. It's an H-beta filter. So there's H-alpha, hydrogen alpha, used for solar stuff, which I'll describe in a little bit. This is H-beta, used for a specific type of hydrogen, and it helps you extract the object from the sky when it's a really hard object to find. Maybe the scene's not perfect or the sky's not as dark as you like to be, but H-beta will help it pop out of the sky. Then you have this one called an O3 filter. It's doubly ionized oxygen, and that's really good for standard nebulae like the Orion Nebula, California Nebula, all kinds of like stellar nurseries and other kinds of nebulae out there that are very popular objects. Trifid Nebula, Omega Nebula, stuff like that. But some more than others. Depends on the color of the nebula and some other structure, some other things about the nebula's development. But O3 is a good overall filter for making those kind of things pop. I have some other filters too, but I just want to show you they're filters you can use inside of the eyepieces to give you other cool things, mostly for visual. You could probably do photography with them, but I don't think anyone really does that I know of. So, of course, you always have to have some batteries because the collimator needs batteries. So these little watch style batteries, flat batteries. This needs batteries. This needs batteries. Various other things need batteries in your setup. So you can always carry extra batteries with your gear because you're in the middle of nowhere. Late at night, you're not going to get it from anyone. So if you don't prepare, you're not going to be prepared at all. And you went all the way out there for no reason. You have a bummer of a night if you can't collimate your scope and you can't use your little lights. Speaking of lights, here's a good little red light you need for looking at star charts and stuff so your eyes don't stop down from brighter lights. You can look at red lights and your pupils still stay relatively dilated. So this is good for reading charts, looking at your instruments, looking for stuff on the ground you dropped. Because as soon as you hit white light to your eyes, the 20 minutes or so it takes, or even longer if you're older, potentially, to get dark adapted again, takes way, way, way too long. So you always carry at least one red light with you. This is a locking one. So you can just hit it once and it stays on, good for maps and stuff. And there's also these little pocket ones you can get on a keychain, have a red LED. So they're all different styles you can get. Some will go on your head, so you have hands-free. So for example, this is a standard headlamp. That's white light for camping, hiking, stuff like that. But you slide to the side, and I've got a red light. Now you gotta be careful if you're in a group of people and you want to switch to red from nothing. You don't want to switch to the white by accident and blind everybody. So always remember which direction the switch is in, and maybe test it with your hand first before you engage it, because you get a lot of angry people that lost their night adaptation for several minutes at least when they get blasted with your white light. So headlamps are great. It's got a little strap on it so you can wear your headlamp. And then another thing to use, let me check the chat real quick. Sorry, I had to keep using this window for that. What's up, Dynamics? How's it going? Hey, Brett. Sorry if this part's boring. I'm going to get to the cool stuff later. I just want to go over a little bit of gear stuff first because it's nice to talk about gear for astronomy. These are the cool things. So whether you're learning the sky or sharing the sky with people alone or in a group or just one-on-one or whatever, you want to be able to point to stuff in the sky. Well, when it's dark, no one's going to be able to see your hand, even if you're dark adapted. And no one can really see where you're pointing anyway when you go, look, over there with your finger. Just go, do you see the finger over there? So the trick we discovered years ago, way before I got into my astronomy club, is people hauling out expensive lasers, which there's enough particles in the air almost anywhere I've ever been where a good green laser, because your eyes are more sensitive to green than red, you will see the whole beam until it basically dissipates into the upper atmosphere, or probably several hundred feet up essentially. But these things are collimated, speaking of collimation, to go quite a long way, because that's how lasers are. They're very precise instruments. So this is an example of a much smaller, cheaper one, although back when I bought this, it takes 2 AAA batteries. Back when I bought this, it wasn't cheap. I think it was like $100 or whatever, maybe $150, because they were so uncommon in a portable size back then. And you had to be careful, because this is a, I think this is probably 15 milliwatts, something like that. So much more powerful than your legally sold ones in the store at around 5 milliwatts or less. This is a higher class laser. This won't blind somebody, but will give them temporary spots. So you never want to point at someone's face. Don't give it to kids. This one especially has no lock. It's just a button. So you can see. And there's not enough particles in this room to see the beam, but you at least see where it's going. It's quite bright. So this is bright enough to use most cases, but it's wimpy and it doesn't really make it easy to find stuff sometimes. It's faint enough that someone's not paying attention, they may not see it as well, or they're not dark adapted enough. So you go to this one, which is basically like, I think this is 70 milliwatts. Uses a special power cell, rechargeable power cell. And this one's brutal. Again, this one has a key switch on it for safety, and a cap that I used to have for it, I lost it. Some have like a twisting diaphragm to close it off. So you have usually 3 levels of security: locking switch, diaphragm, and a button that doesn't lock. Those are 3 basic safety things in all these lasers from China, essentially. So this one's about, last I checked, it was, I think, about 70 milliwatts. And check this thing out. It's very, very bright. Much brighter. I can't even look at my hand. It's too bright. Much brighter than the other one I just used. I also have a blue laser that's actually 1 watt, which is insane when you think about it, because it will actually burn things. And it sends out the coolest Star Wars laser lightsaber thing you've ever seen in the sky. But this will too, which is a much smaller beam, but it's very bright green, great for pointing, has safety features that I never use, but they're here. I also put this little thing on here, just a poor man's protection, so I don't trigger the switch in transit and hit the button to drain my battery. It's just a little pin cap taped on top of the hole, on top of the batteries of the switch, so I can't trigger it by mistake. Because occasionally I've gotten to this place and it's been on in my bag, and I kill the battery. So this is, I haven't had to charge this battery for a couple of years. Still works great. So lasers are excellent for educational use. You get a lot of ooh-ahs if you're in a group, like, ooh, look at that, ooh, wow, ooh. And they often like that more than the astronomy part. But hey, you know, you got to get people excited. And if you know what you're pointing at, they know exactly where you're pointing. And what's kind of fun sometimes, if you know an object and your friend doesn't, and he wants to find it in his scope, and he's not good at star hopping like you are, you can point this at an object and he will move his scope until he finds the beam in his scope. And there he is. So you can be like a human starfinder for somebody to help them find some objects on their own, you know, without using a computer and not knowing how to use this Telrad thing I was talking about. You can also kind of fake that with this. But again, you always want to be careful where you're pointing it. Don't let kids use it. Definitely don't take it out when people are taking pictures. You'll ruin all their time exposures. But when you're out just showing people around and teaching people about the sky, they're indispensable. And not that expensive these days. This one from China, I think, was like $30 or something like that. And the problem is there was a clampdown for a while because people were buying these, using them, shining them at airplanes, using them at concerts, and some of these are very dangerous. You don't want to shine this one in someone's face. You could do some damage with this one in someone's eyes. So you have to be responsible with it. So China had to start reclassifying these for customs as like a flashlight, even though it's a laser, it's not a flashlight. So for a while they were hard to get online. Now I think they're back to being easy to get online. I haven't tried since these worked for a long time. But so if you start looking for these online, just I have to hunt and peck a little bit. But you want to look at the MW, the milliwatts, and you want at least for a good night use a green. These are basically neodymium YAG lasers, diode lasers, and so look for ND-YAG or just diode laser, 15 to 20 milliwatts if you can. Much higher than that, it's overkill. This is overkill, but I'm happy with the higher power one because it's fun. And I used to work at a laser company, so I've been in labs with crazy lasers. I like lasers. So, a couple of the quick things before I get to the fun stuff. Red acetate of some kind. This is all taped up, but this is cut to the size of my iPad screen. So when I had some iPad apps that didn't quite have a night mode in red, or not all of it was in night mode, I used to tape this over my iPad so I could use my star programs on my iPad at night and not blind myself. So this is also good for putting over normal flashlights to make them red, putting over your iPhone to use the same thing for star programs and other kinds of useful stuff for astronomy. So these are cheap stuff you get at an art store, very useful. And then you always got to clean your optics, and you don't want to wipe with a cloth, especially if you have junk on the cloth. If it's dark, you can't see if you have grit or dirt or something like that, and you just scratch the hell out of your lenses or your eyepieces, or get oils from your fingers on there. So this little fun rocket ship thing that stands up on its own is a great, instead of the canned air, you just, this is perfectly strong enough to get stuff off of here. You just got to pump it quite a bit. And it's infinitely reusable versus a can that runs out and you got to go buy another one. So you need to clean your optics. That's a good thing. You can get other special cloths to clean it, but again, you got to be very careful. Make sure they're stored well. They're not filled with finger oils from your fingers or your face if you touch your face, and grit and particles that get on it. So when it's dark, you can't see what you're doing. In the dark or with a simple red light, I can see this, and I can quickly get some dust off my eyepieces. So very useful to have that stuff. Okay, now we're going to get to the better things. I don't need this video anymore. I can switch back to the chat. And I can go on to sharing some web pages and fun things about upcoming events. Make this a little bit smaller. Come on. And I can see what you guys are saying, because with the having to watch the video and all this crap on my screen, I couldn't see what was going on. So sorry, it wasn't as dynamic on the gear discussion on the chat, but it's fighting for real estate. Okay, so let's fix the camera so you can see the screen better. Good old. Okay, that's pretty good, I think. Get the gist anyway. Cool. Good as YouTube can make it anyway. This doesn't let me control the camera other than pointing and zooming. So. Yeah, so I see you guys talking about the Aurora stuff in the chat. So I had some here. The only real good one I ever saw from here was in the late 90s, back when I used to watch TV news and stuff. I was home from work, hanging out in my apartment, and the meteorologist comes on and goes, "Oh, if you go outside right now, you can see an aurora." And I was kind of tuned out at the time. I was doing astronomy here and there, but not as much as I have been for years. And I said, "Oh, no way, you can actually see this from here?" I ran outside, and it initially wasn't that impressive, but then you dark adapt, your eyes start seeing more detail, and it was pretty cool. You got this kind of a red wash to the sky, and this kind of a white searchlight pattern that kind of, you know, goes very big, fuzzy white searchlight pattern across the sky, along with the red glow. It was really interesting, weird. It wasn't green like you guys have up in the north. And I've seen, see, when the first aurora came back, was it last year maybe? A couple years ago, there was another one that come through. This year there have been a whole bunch. End of last year, I think, and this year there've been a whole bunch of them, bunch of activity. And I keep missing them because it's just not good from here, or the weather sucks. Go outside and it's not visible at all. But I have friends up north who get some clear pockets once in a while, and because they're further up north, they actually get the green color up in like Washington State, things like that. And he's got some cool footage of that. So it's nice. One of these days I'll get to see a proper one in green, maybe in Alaska or something. I'll have to go out of my way to go check it out. But the aurorae are very interesting. So so I have seen it from here. It's just not what you guys are seeing. It's just a weird version of it. But it's still cool, just nonetheless, considering what it really is. You know, it's the solar wind hitting our Van Allen belts and get excitation, and it's really, really cool stuff. Anyway, so I want to go to a couple quick websites and some activities coming up. So Astronomy Magazine's pretty good. I don't know if you guys get that. You probably get that in the UK and other places over there, but it's pretty much a universal, like, worldwide magazine. But I used to get it over Sky and Telescope because generally had more beautiful pictures and kind of a general gamut of things, not so nerdy as Sky and Telescope is. Sky and Telescope's a great magazine, but as I was a beginner for a couple years, I was like, I think I'll stick with astronomy for now. And they published books, and they had you know, other stuff that I enjoyed quite a bit. So I stuck with Astronomy Magazine for years, and then eventually started using all these magazines. But their website's pretty good. They always have these, like, the sky this week, the sky this month. So real quick and dirty. So if you don't have astronomy apps on your phone or on your iPad or on your computer you lug around, the websites are often quite good, giving you, you know, events and dates and things like that. We even talked about the solar eclipse we had, as well as the annular eclipse. So let me go to this page. So recent stuff with the comet has been very interesting, and I will try to pronounce the name. It's like Sushinshan, something like that. Also called Comet C2023A3. That's what most people are calling it. And it also has the name Atlas in there, which I think is the name of the system that also co-discovered it. Usually when it has a name like Sushinshan or Bradfield, it's somebody's name who discovered, like a comet hunter. But ever since they had these near-Earth asteroids and other warning systems put in, there are a lot more systems now discovering comets more than people. So I think Atlas is one of those systems, but maybe it was discovered around the same time, so they gave the guy credit as well as the system name credit. Because some of the comets we had not too long ago were just funky names. They weren't someone's name. They were just some kind of nerdy technical name with some letters and numbers and stuff. And those are ones discovered by machines, not by people. This early warning system and other systems out there. So anyway, so someone took this picture. What was the detail on this? I forgot. And the stupid website has ads, of course. I have to worry with these stupid ads. Let me quickly look at a footer on this. There's a 30-second exposure, a Nikon DSLR, and Brazil. And back when it was still a morning object before it got close to the sun. So it's quite beautiful. And my friend who works at NASA does a lot of stuff about the moon, a lot of moon mission stuff with Laddie, L-Cross, all kinds of other stuff. Really interesting research. And he took this picture a few mornings ago. Really tough because it's super close to the sun at this point, so it's dawn before the sun came up. And like right now, I'll show you another picture that shows how far away it is right now, because it's still too close to the sun. It's going around the sun, and by the end of this week, it will start to be visible as the sun goes down at night. And so it'll be up when the sun goes down, but still be pretty close to the sun. You might have to wait till next week till it's really separated. The problem is, the longer you wait and the further it gets away from the sun, now it's less bright and the tail is less impressive. So this is the juggling you have to do. You want to get it close to the sun if you can, but not so close you have to worry about hard to see or need the right protection for your eyes so you don't blind yourself, all that kind of stuff. But so he took this shot from Lick Observatory up on Mount Hamilton. I've been up there many times. Really cool, but nice long tail. And then there's some other cool shots of it I found online. This is cool because it shows the gas tail separate from the debris tail. So you get this quite a lot based on the comet's trajectory and stuff. Quite often they're in line, but sometimes they're not. You get this nice separation of the gas and the debris. And occasionally you get like a secondary tail. This one looks like it's starting to form a secondary tail of debris based on the angle it's getting hit at from the sun. So beautiful stuff. And then this is a cool map, a cool animated sequence showing the comet over the next several days. So we're at the 9th right now. So as you see, even in a couple more days, it's still pretty damn close to the sun. So you have to, even if the sun goes down, you have to have an amazing horizon, no haze, no clouds, and really look very quickly before it's gone. So it's probably better to wait till next week if you're going to go looking for it, just so you can have a chance to have the sun go down, have the sky get a little bit darker, and a nice separation of the comet from the sun. But like I said, as it goes further, it gets less bright, the tail gets less impressive. So if you're taking pictures, it doesn't really matter so much, but if you're trying to visually observe it, it might be less pleasant the longer you wait. Anyway, so that's a nice little animation showing that process there. And then this is a cool shot, I thought, as well. This guy took in Texas. Nice pre-dawn shot of it in Texas. Pretty cool. My first comet ever, it wasn't Halley, actually. I got into astronomy pretty heavily after Halley. I mean, I had time to see it because I was junior or senior in high school when Halley came through. I just wasn't into it as much as, you know, even though it's this got to see, you could see it twice in your lifetime, potentially, whatever. I was like, you know, I'll see it. And then I found from a lot of friends from this area, it was kind of shitty. It was low on the horizon, so it's in the muck of the thick part of the atmosphere. You know, the lower you look through the horizon, the more atmosphere you're looking through versus looking up at the zenith, right above you. So that's why you generally wait till objects are at least like 30, 40 degrees up or right above you before you look at them if you can, instead of right low, low, low. Unless you're like at extremely high altitude, perfect weather, everything's just right, then everything's going to be kind of swimming in some watery appearance of the atmosphere dancing around. So I heard from a lot of people Halley kind of looked like that here when it was at its best. So I kind of didn't feel so bad about missing it because it didn't sound like it was like you could say, oh, I saw it, but we weren't going to get a good look at it. But the following year, I think it was, Comet Bradfield came through, and that was glorious. So good I could even get a great look at my new cheap camera store telescope I bought with my own money for like 120 bucks. And a little, Tasco, I think it was. Just a really cheapy Tasco with 0.96 eyepieces and was it 50 millimeter, maybe 60 millimeter objective, so it wasn't big. But it ended up being a great scope for planets, comets, some double stars. I actually learned a lot using that stupid little scope in my backyard, freezing my ass off some of the time. Until I got more into the telescope use at the club and going to club events, looking through big 16-inch reflectors and all that fun stuff. Getting checked out to use it myself, and eventually saving money and buying my own gear that I could drive around, going to Yosemite every year, stuff like that. So anyway, this starting small is not so bad. Now the scopes you can get now for the same amount of money or slightly more money, it's like synthesizers, like all the Behringer stuff and all the cheaper Roland stuff and all that is pretty damn amazing. And Korg for the money compared to what it was, 20, 30 years ago, just like telescopes. So, I mean, some of the really cheap scopes for $200, you get a go-to system like this, this thing I showed earlier. So, it's crazy. It's just, things have changed so much. So that's the comet stuff. And so I'm going to be tracking it, and if I have time and it's decent at the end of this week, I'll probably try to do a live stream of the comet. At the very least, I will get it some next week when it's clear, higher above the horizon, away from the sun, as an evening object. But so that's the comet stuff coming up. And just to give you a quick idea, if you haven't used this before, this is the Sky website. So if you don't own any software and you don't want to buy any software, there's web-based software like the Sky. And so you can actually go in here and you can search. Oh, actually, no, I can do this. Go to the menu, go to Bright Comets. Right up here, C 2023-83 is right up top. Click on it. There's a little map. Shows you where it is right now in relation to the sun. So it started over here, and it's coming over here, and eventually it's going to come over here. So it's in Virgo right now, which is a shame because I didn't get a chance to look at Virgo much during the summer. And Virgo has amazing galaxy clusters in it, so I'll have to wait till it comes out of the sun again. But so yeah, the comet's going to keep going across like you saw in the little animation, and pretty soon be well above the sun as it sets, so you can get a nice look at it. But what's fun in the software, just like any other decent software, is you can go, well, I want to see what's going to happen in the next couple of days. So I'm going to the 9th, I'm going to go to the 10th, and visualize. So it's showing, it's obviously not live sky because the sun is down where I am, but it's showing you where it is in relation to the sun right now. And you can go in here to the timer, and you can look at it change. I don't know why, I think this overlay turns this dim for some reason, which is kind of annoying. But if I turn this up so it's a little bit bigger, you can watch as I click the dates. So the 10th, 11th, 12th, 13th, 14th, etc., etc. So by the 14th, it's quite a ways away from the sun. And probably, does it show the tail getting smaller? I forgot. Yeah, you can see the tail is going to, it's a real rough approximation, but it does show the tail getting a little bit shorter as it's going further away. So it's less impressive visually, especially if you're taking photographs to get the wispy tail. So the Sky is pretty cool online. You can do all the stuff. You don't have to buy anything. You just run your browser. And it's pretty cool. There are other options as well, but I just picked this one because I could easily find the comet in this one and show it to you guys. So that's that. Some other fun stuff coming up is, let me check the chat real quick because I'm missing any stuff you guys are saying here. I'm at the Aurora, I'm at Pix, Hail Bop, yeah, remember the cult, the Hail Bop cult with the the purple tarps and the Nikes. And they all took cyanide and thought they were going to travel up to the comet. So crazy. 12 hours before live stream. Yeah, I'll try to make an announcement on the I guess I call it community tab now on YouTube. It was called message or chat or something, but now I think it's called community tab. So I'll put a message out in there. I don't know if I can do it 12 hours ahead because it's all weather based. You know, the weather's, especially as getting into fall here and stuff, and eventually into winter. The weather's getting more and more unpredictable. We've had a lot of nice weather lately, but still some clouds and some haze and some other stuff. So I can roughly plan something, but it's really a by the seat of your pants thing when it comes to the sky. You just never know. Because I don't want to set up all this stuff and spend all the time calibrating, collimating everything, get everything all dialed in, and I go, oh, the sky sucks. So it has to be pretty good for me to want to take all my stuff and set it up. If I had another scope that wasn't, you know, it didn't take me like 15-20 minutes to set up, I could just quickly go out and just move it. Maybe I'll use my Dobsonian, the big reflector, and I could just hand move it. That takes a little less time to set up, but it's also kind of bulky and a pain. I gotta find a good location. So it's all up in the air, but you just hear me complaining. Sorry about that, but it's just, you never know with this stuff. It's nice when you have an observatory set up somewhere. You can just go and turn it on, just like you have your studio with your gear ready to go. And since my stuff is all geared around mobile for telescopes, I have to set up, configure every time I do it. So it's a little more of a pain than just turning it on and going. But I enjoy doing it no matter what, so I'm definitely not complaining. So now some cool stuff with asteroids coming up I want to talk about real quick. There's this asteroid pair, and it's called, make sure you get the name right here. They did a test last year, I think it was, or 2 years ago. There's a video of the launch of this current event, but they took, it's a double asteroid redirection test called DART. And they did a thing where they tried to impact one of the asteroids with a probe, essentially, to see if they could knock it off trajectory. Because it's not just an asteroid coming through, it's an asteroid gravitationally bound to another asteroid. So it has even more kind of stuff going for it, throw it off course. And it did work. Let me check the date here. I forgot the date on this thing. Sorry, I was going to take some notes on this, but I thought I could wing it. So this one called Didymos. It's the Didymos asteroid system, and the smaller one, I think, was thrown off course. So they had this mission Hera that was just launched a couple days ago, I think, that is going out there to survey the lasting result of the impact. When they measured the impact a couple years ago, when they did it, it was significant. But is it going through gravitational effects, kind of regain its position next to the paired asteroid, or is it further knocked off permanently and just going to continue its orbit around the other one at a different distance? So that's what Hera is going out to do. It's kind of interesting. I was not aware of this. I just did some online reading about this stuff. But yeah, Dimorphos is the one that was hit, and the Hera mission is going out to check on it. So there's a little video of the Hera launch a little while ago, and this stupid ad's getting in my way. I hate this stuff. These websites are free, and they gotta make it a pain in the ass to use. Anyway, just a real brief thing on that. But brought up another interesting thing because most people don't really talk about asteroids much, other than the fact that they're threats to us, and they're possibly, excuse me. Oh, here's the note I was looking for, I think. Yeah, September 26, 2022, they, wait a minute, no, they announced on October 2022, October 11th, the analysis of the data showed that DART was successful. And so that's why they launched Hera. And there's an article about this NASA study after DART impact. So there's a whole thing here about the actual images of the asteroids. There's the two together. And it talks about the whole thing about this little duo that they've been experimenting with. So it's kind of fun. I mean, they're screwing around, they're changing, altering some stuff in space, but hey, if it's to protect the Earth from more collisions, that, you know, kind of stuff that's extinction level events, like took the dinosaurs out, then it's good to study that shit. What made me think about some asteroid stuff that, again, people don't talk about on much. So I wanted to just quickly go over some nerdy asteroid stuff just for fun. So they're often referred to as minor planets. They're usually, you know, a lot of them are around 1,000 kilometers or less in diameter. They usually orbit in the, you study this in school when you're a kid, you know, the asteroid belt between Mars and Jupiter. And it's still the bulk of them in that asteroid belt. But what's really interesting is all this stuff that has happened as we analyze stuff over the years, and decades. All these guys did all these, even from simple photographic plates to just visual observations and stuff, to learn about these interesting like voids and regions of the belt. So they have this, I wrote this down here and I didn't footnote it properly here. They have these regions. Where the hell did I put that thing? Sorry, my notes are all screwed up here. I kind of reformatted them and everything got all screwed up. So the measurements of the stuff is you know, it's pretty big stuff. So 1 AU astronomical unit is 93 million miles from Earth to the Sun. So that's our standard candle for measuring large distances in the solar system, at least. And so the asteroid belt generally falls between just over 2 and just past 3 AU. So it's between Mars and Jupiter. So that's considered the main asteroid belt. But they have these like thing called Kirkwood gaps that they study over time because of the influence of Jupiter, and as Jupiter moves around the parabolic path in the the elliptical path of the of its orbit. So point where it's closer to the sun and farther away from the sun because it's at one focus of the ellipse. And as it's moving through, it's creating effects all around it, not just from its radiation, but also its movement is causing all these minor planets to also be affected. And so you have these Kirkwood gaps, and there's some other terms for some of the other smaller variations in there. And it's interesting you have these kind of voids where you don't have as much activity as you would think you have from a belt of just gravitationally bound asteroids. But you also have these other phenomena with these Earth-crossing asteroids and Mars-crossing asteroids and asteroids beyond Jupiter and even beyond Neptune. And so they have these different terminologies. So there's the Earth-crossing asteroids. There's a group called Apollos, and another one called A10s. And so the Apollos are about 1 AU plus or minus, so they're kind of close to our actual distance from the sun. But only when they get to the closest point of the sun do we actually kind of potentially interact with them. That's when we can have some collisions and stuff. They're not just rogue asteroids, they're on trajectories. The A10s are inside of that path, so they often get a lot closer to the sun than the Apollos do. So they actually cross inside the path of the Earth. But I think the Apollo ones are probably a little more sketchy. But again, I'm not analyzed this by any means. I'm just going by what the measurements are. But they have other weird ones like this one asteroid called Phaethon, which has this crazy path where it comes all the way from the main belt at what they call aphelion, so the farthest point from the sun, to its perihelion, which is 0.31 AU. So it's got this crazy ass thing, goes way past Earth and way out to the asteroid belt. So you have these weird paths on some of these asteroids take. It's really, really bizarre. And then I said you had the Mars crossing. There's the close Mars crossing and the far Mars crossing. And most of them, even the closer one, doesn't get that close to Earth, but it's close enough that if something were to throw it off, it could continue on and come toward us. So there's all this stuff you have to worry about as you study this stuff more. And like, no wonder it's a wonder we're not getting bombarded. You know, if you look at the far side of the moon, which has taken a lot of the brunt of a lot of stuff that was kind of heading our way potentially, since we're locked in orbit. It was a nice shield for us. If you look, it's totally peppered with all kinds of stuff over a long period of time. And just think of all the stuff that could have hit us and stuff that could still hit us. That's these wandering asteroids. But there are a lot of really cool asteroids. I showed on the last time I did a live stream, the one NASA Explorer site, that not only can you in 3D look at the orbits of the asteroids, but you can actually virtually stand on them from the 3D data they collected in the orbital paths and pretend like you're on a mission on them. And it's really fun. You can zoom in, look at all kinds of details on these asteroids. The bigger ones like Ceres, Eros, Pallas, Vesta, the stuff that's often on star charts and astronomy magazine, Sky and Telescope, that you can actually see in a telescope. Because Ceres is like one of the biggest ones, if not the biggest one. And it's considered in the dwarf planet category like Pluto is now. So, because Pluto got demoted, guys like Neil deGrasse Tyson, other people think it should have been demoted. And so, but Ceres is right up there. Ceres is a huge asteroid. So when you go look at that NASA program, I don't remember the website now, but if you go back to one of my previous streams that wasn't on the telescope, you'll see it. And fascinating stuff. So that's some asteroid stuff. Just kind of threw out a bunch of quick things. Then there's some other events. Obviously, we had the annular eclipse recently that I didn't do a live stream of that. I did a live stream of actually, no, I did one of the annular. The annular one we had many, many, many months ago. There was a recent annular that was not really visible from here. So I just watched the websites, people broadcasting from their area, like South America, stuff like that. They had guys in Easter Island showing some stuff and all that. Those are kind of fun to watch if you haven't seen them. Go look for the annular eclipse that they had recently. But we had an annular eclipse, was it end of last year or earlier this year? I totally forgot. And I did a live stream from my scope. I only got a piece of it because it didn't show up annular here. It was only partial because it was not on the path of annularity. But you could still see, Pac-Man, you got chunks taken out of the sun and all that. There were a bunch of you guys in there live streaming with me. It was kind of fun, a little chat going on for a while. And then, um, as usual with this stuff, it's kind of fun. If you don't have safe equipment to look at the sun, like special filters, special glasses, special whatever, and you don't want to watch a website, you can also use pinhole cameras. So I did a pinhole camera of one a couple years ago. Didn't turn out too well. But what's fun is the gaps in the leaves of trees are so tiny, they act as a whole bunch of pinhole cameras. So if you look at during an eclipse, you look at the ground under a tree that has the right amount of leaf coverage, the right amount of gaps, and you see little tiny images of that crescent or that little bite taken out of the sun all over the ground because it acts as a pinhole camera. It's a very clever little hack where basically you just stand there. You don't have to do anything. You just watch. And you can take pictures of the ground. So that's kind of fun. So that was back then. So anything else on this thing for this period that was interesting? And they're just showing some other stuff you could have seen that week. For this week, other than the moon thing they're talking about here, did have a nice little Moon-Venus conjunction a couple days ago. I missed that because the weather was shit, but I had some clouds or whatever, so I couldn't see it. But this is fun, these sites, for these little things. You don't need any optical aid, you don't need a telescope, you don't even need binoculars, but binoculars are good enough to do stuff. And you could have seen little things like this. It's kind of fun, even your naked eye. What else was going on this time? This was, oh yeah, this was showing this is the comet, I think the comet thing, I think. No, this is something else. It's showing the moon and Antares at conjunction. So, oh, and sometimes they have other minor planets. This is the asteroid, what is it called again? Letitia. This is the path Letitia's taking in October. And of course it's not they have some text that describes the area of the sky, but sometimes, oh, it's in Cetus, okay. So Cetus the whale. So it's a southern object. So yeah, you have little charts in here that show you this kind of stuff. And you need charts for these kind of things because they just come up as tiny little points that look just like any other star. So without an actual dedicated chart like this, or even better than this, you could not find Letitia. No way. You need to have some kind of a chart that will tell you what it is. So if you don't have the software, you can have a printout from the website. You can have the magazine that shows it. This is how I used to do it with some friends a long time ago. So I would just have whatever magazine was current, and we would try to go, is that it? No, is that it? I think that's it. And then if you have someone have to have some software that same night, we would just compare it and go, oh yeah, that's definitely it, because their software shows lower magnitude stars with this, or just higher magnitude stars, lower brightness. And so they would have a nice, this is pretty sparse here. So you need a lot more stars in the area, most likely, to match, to know what you're looking at. So anyway, these sites are fun for that. And then I was going to quickly go over some solar stuff, which is fun, because I am working on getting a solar scope for doing some daytime streaming. Just didn't have the money. So, wait a minute. Oh, that's the Sky Telescope thing. There we go. This is the company I'm going to buy a scope from. Lunt makes some really good lower cost solar telescopes. So one of the fun things about solar is you have different wavelengths to look at, different details, different things to see, not just an eclipse or some kind of other special event like that, but just daily you can go out and look at the sun. Now this is a nice split screen image showing you hydrogen alpha versus visible light, or white light as they call it. So in white light you can see sunspots, and you can see detail in sunspots. You can see the umbra, which is the darker spot, and the penumbra is a little softer edge to it quite well. Even on a projection, if you don't have a thing you can safely look through without killing your eyes, you can project it on a piece of paper or put it in a black box so it's totally dark and get a bright image inside the back of the black box. So that's one way you can look at it. This image has been color corrected because in general H alpha is a very reddish look, and so this on the right, this would be a reddish view, but you still get this speckling granularity, which is basically just tops of convection current columns of plasma, which is fascinating. I mean, it's not just convection currents of gas, it's actually plasma in these magnetic loops going up and down. So you're seeing like a cross section as you're coming up and down through the sun, and then you're getting also these filaments, which are really prominences on edge, because this is a prominence from a side view. But coming at you, they look like this. So you get this granularity, you get these little filaments, or snakes they call them sometimes. Filaments on their sides, which are nice prominence. These giant plasma loops coming off the sun, looping around. A lot of these plasma loops are, that's like 3 or 4 Earths across right there, probably. Doesn't look that big, but it is. But you can see, if you zoom in enough, you can see this detail. It's really, really cool. So in a decent H-alpha scope, even a modest one, you can see some of this. Maybe not quite this detail, but pretty impressive. So the trick is to set up one scope. It's white light with a special kind of aluminized mylar or some other kind of filter that cuts down the light, so you get this kind of a yellowish orangey glow to see this. And then the other side, you set up another scope with H-alpha, you see all this stuff. A lot of times people shoot them in black and white, so you get more detail, because the reddish color is interesting, but also tends to get kind of muddy looking. So that's why they often do this false color to yellow or to black and white instead of the red of the H-alpha. So it's fun stuff. But there are other things online you can look at. They're always doing other measurements in different wavelengths. So this thing called SOHO is here. And you have this extreme ultraviolet imaging. So the EIT is extreme ultraviolet imaging telescope. And they use these different wavelengths of ultraviolet for different things. They all look pretty similar other than the color. This is false color. But they're revealing different characteristics of the, in this case, this is supposed to be analyzing the corona. And according to this article, the 171 is looking at the lower corona. So the corona is when you see the solar eclipse and you see the big halo around the sun, and at the poles you see the spikes coming, north and south poles you see those little spikes. That's all part of the corona, which is the outer, technically outer kind of, lack of a better term, atmosphere of the sun. And paradoxically, the corona is hotter than the core. And so they say in this lower corona shot, the temperature is 1 million degrees Kelvin. So, that's pretty hot stuff. And so they're looking at different structural things, and it's because they know how the different elements react at different phases of the sun. They're saying it's looking a lot at heavily ionized iron and helium, different ionizations of iron and helium for these structures. Pretty interesting. I didn't get down to here yet what these are doing. This is a magnetogram, so this is like magnetic pole, magnetic interactions, because again, these are electromagnetic in nature, because it's plasma. There's charge and there's magnetism that's forming these loops that makes them go from point to point, those prominences. And then there's other fun, I don't know what these are. I haven't read about these yet, but it's more the corona, looks like. Some weird aspects of the corona. They put a blocking disc in here to block out the sun, just so they can explore the corona by itself. There's a trick we did all the way back in '88, looking at Mars when it was at opposition, meaning opposite the sun in the sky, and it was also at what you call perigee, so close to Earth and opposite the sun in the sky, like perfect storm, perfect condition for Mars. And it got so close, you could see surface features, you could watch the dust storms come through and cover an area and then reveal an area. You could watch the moons go around Mars. You could watch Phobos and Deimos, which are basically captured asteroids, disappear behind Mars and come back out again, because they travel quite fast. So we're up there quite late at night, and this guy read some article, and he's like, oh, I think I can put an occultation disc in the eyepiece, and I can block out the disc, and we can look for Phobos and Deimos. So we did. And this is me not long out of high school. I'm like, that sounds fucking crazy. All right, let's do it. Because it's his scope, and I'm just along for the ride. I'm enjoying learning stuff and watching. And sure enough, we found Phobos and Deimos. And they weren't out for very long, because they cruised behind the planet not long after we saw them. They're moving real fast. And if we'd stayed there all night, we probably could have seen them come out the other side. I think their orbital period's pretty quick. But anyway, we got to see them both before they disappeared. It was just pretty spectacular. Opposition again at 93 up at Yosemite. That was also really special. But no one is looking at the moons that night, or that couple nights, I don't think. But still amazing views of the planet. Just stunning views. And I've been looking at it off and on for years, but it's never been as good as that. I always catch it at the wrong time. So Mars is very interesting, but it has to be big and it has to be just right to really be stunning. Anyway, so this is the SOHO website. Just look up Solar and Heliospheric Observatory. That's kind of fun if you want to learn more about this weird solar stuff. And that was pretty much what I wanted to go through. A little bit about some gear, a little bit about current events, comets, asteroid stuff, a little bit about solar, because I'm going to gear up as soon as I have some money to get some solar stuff. I already have white light filters, and that's how I did the partial eclipse stream. I guess it was end of last year with my big telescope, but it doesn't have a clock drive on it, so I had to constantly adjust the scope as the sun moved out of frame, since good old Earth was rotating. So, but I need to buy a white light filter for my mobile rig with a clock drive on it. And then I have this dedicated H-alpha solar scope, and I can have two scopes going at once, and use kind of maybe a switcher or some kind of combo box, and I can have a split screen or switch between them quickly, white light, H-alpha in the field, to stream. So that's my next major plan, other than doing some random stuff with my scope as it is. So, but that's about it. So I think some of you guys may still be here. Maybe not. Not sure. I've been peeking at the chat a little bit, but I'm a little behind, so sorry about that. But I'm probably going to call it, unless you guys have any other comments or questions about stuff. Again, this is a huge subject, so I could do a whole stream on just, you know, one asteroid and all kinds of cool animations from it, and pictures of it, and history of it, and all that kind of stuff. But I try to dabble in a bunch of different stuff. I don't focus too much on one thing just because it's all pretty interesting to me. And I don't want to have one thing too long on one specific item because, you know, this is a sharing experience, and I want people to enjoy this and not be bored out of the skull. So I do hop around a bit, whether I'm on the scope or whether I'm on a stream talking about the stuff, just to eventually hit a subject somebody likes. Anyway, thanks again, all you guys who are here or who came and went, or anyone who watches afterward. And looks like this little experiment worked with the phone and the computer together. So thanks, Brett. Looks like dynamics already took off. And I haven't seen Neil for a while, so he probably took off already as well. And of course, Neil has a telescope with remote capabilities. We keep talking about doing a thing from his scope one time, having me remote controlling it across the Atlantic to do something with it. So it'll be fun. I think it'll be interesting. He definitely has better gear than I have, because mine won't do that. At least not the setup I have. And he probably has a much bigger scope as well, which is cool. So I'm looking forward to that at some point as well. Hopefully I can maybe turn that into a stream as well after some experiments. So more fun to be had. But thanks again, everybody who was here and who will catch it on the replay. And always feel free to jump in chat whenever you feel like it, or make comments after the fact. And always happy to share stuff with people and have some interactions. It's a big part of the deal. Otherwise, it's just me goofing around with stuff, and I could do that without a stream. But it's good to share things and get people excited about science and the universe and all that. So, as the guy said on one of my favorite astronomy programs ever, Jack Horkheimer, the Star Hustler, keep looking up. And see you guys later. Thanks again.